False discoveries. The false discovery rate is a popular way of measuring accuracy because it reflects how experimenters make decisions. It is usually only the significant results, the discoveries, which are acted upon. Hence it can be very valuable to know the confidence with which you can report on those discoveries. False discovery rate is a measure of accuracy when multiple hypotheses are being tested at once. For example, when multiple metrics, or variations, are being measured in a single experiment. The advantage of false discovery rate is controlling for the FDR is a way to identify as many significant tests as possible while incurring a relatively low proportion of false positives. Using the FDR allows scientists to decide how many false positives they are willing to accept among all the results that can be called significant. When you report your results, you should make FDR to 0.1 or 0.05 unless you have a good reason not to. Your report will be consistent to the literature because other people also use 0.1 or 0.05. If you set your FDR to something like 0.0456, your paper might be rejected for inconsistency. In medical testing, the false discovery rate is when you get a positive test result but you don't actually have the disease. It's the complement of the positive predictive value, which tells you the probability of a positive test result being accurate. The FPR is telling you the proportion of all the people who do not have the disease who will be identified as having the disease. The FDR is telling you the proportion of all the people identified as having the disease who do not have the disease. Both are therefore useful, distinct measures of failure. The total number of rejections of the null include both the number of false positives, FP, and true positives, TP. Simply put, FDR equals FP, FP plus TP.
The false discovery rate is calculated by dividing the number of false positives by the total number of positive tests. To help us understand this equation, we're going to imagine that a group of people are being tested for a disease. This yellow line represents a cutoff level for a test. To the left of the line, the test returns negative, and to the right, it returns positive. Since the false discovery rate only takes into consideration people who test positive, we are going to focus on the squares to the right of the yellow line. When trying to determine the false discovery rate, we only need to use the top row of the sample table. This row is used for people who tested positive. In the left box, we have the true positives, in the middle box, the false positives, and on the right, the total number of positive tests. Counting the squares, we find that there are 53 true positives, 7 false positives, and 60 positive tests in total. Now all that's left to do is enter the data into the equation. In doing so, we find that the false discovery rate is 7 over 60, which is 12%. Once more, the false discovery rate is calculated by dividing the number of false positives by the total number of positive tests.